Have you ever found yourself asking why certain people seem to effortlessly dodge COVID-19, while others, even in the same household, can't seem to escape its clutches? The answer isn't just a matter of luck or chance. It might actually be hardwired into our genes and immune systems. Recently, a groundbreaking study has provided some answers to this puzzling phenomenon, offering new insights that could change how we understand and approach viral infections. Over the past few years, the world has watched as COVID-19 swept across the globe, infecting millions and altering the course of history. Yet, amid the global pandemic, an intriguing question has persisted. Why do some people seem immune to the virus while others are repeatedly infected? Scientists from University College London, the Wellcome Sanger Institute, and Imperial College London decided to dig deeper into this mystery. What they found is not only fascinating, but also holds the potential to revolutionize our understanding of how the human body interacts with viral pathogens. The study that could change everything. To explore this enigma, the research team embarked on an innovative study. They selected a group of unvaccinated volunteers who had no prior history of COVID-19. These individuals were intentionally exposed to a very low dose of the original strain of SARS-CoV-2, the virus that causes COVID-19. But this wasn't done in a reckless manner. It was carefully controlled through nasal spray administration, ensuring that all participants received the same exact dose. What makes this study particularly interesting is how the researchers monitored the volunteers throughout the process. They didn't just observe whether or not the volunteers got sick. They delved into the microscopic details of the body's response to the virus. Samples were meticulously collected from the volunteers at various stages, before exposure, immediately after, and at regular intervals during the study. These samples included tissue from the area between the nose and throat, a key site where the virus tends to establish itself, and blood samples, which provided a wealth of information about the body's immune response. The goal was to understand the full timeline of infection, from the initial viral encounter to recovery, and to see how the body's defenses either succeeded or failed in combating the virus. The surprising results. The results were nothing short of surprising. Despite all the volunteers being exposed to the exact same dose of the virus in exactly the same way, their outcomes were vastly different. This observation alone challenges the simplistic notion that exposure inevitably leads to infection. Instead, it highlights the complex interplay between the virus and the host's immune system. The study identified three distinct patterns of response among the volunteers. 1. Sustained infection. Some volunteers developed a sustained infection, experiencing cold-like symptoms that indicated the virus had successfully established itself in their bodies. These individuals tested positive for COVID-19 and had to endure a period of illness, albeit not necessarily severe. 2. Transient infection. A second group exhibited what the researchers termed a transient infection. These volunteers briefly harbored the virus but quickly fought it off, displaying only mild symptoms, if any. Their interaction with the virus was short-lived, and they soon returned to a state of health. 3. Abortive infection. The most intriguing group was those who experienced what the researchers called an abortive infection. These volunteers did not develop any symptoms and did not test positive for COVID-19, despite being exposed to the virus. It's as if their bodies rejected the virus outright, preventing it from gaining any foothold. This phenomenon of abortive infection raises several questions. How can a person be exposed to a virus and yet remain completely unaffected? Is there something unique about their immune system that offers this protection? And perhaps most importantly, can we learn from these individuals to better protect others in the future? The role of the immune system. To understand these differing outcomes, the researchers turned their attention to the immune system, specifically looking at the timing and nature of immune responses in the different groups. One of the most striking findings was related to the group that experienced transient infections. These volunteers, who managed to fend off the virus quickly, showed a strong and immediate accumulation of immune cells in the nose, just 1 day after infection. This rapid response appeared to be crucial in preventing the virus from taking hold and causing a full-blown infection. But it wasn't just the speed of the immune response that mattered, it was also the specific type of immune response. The study identified a particular gene called HLA-DQA2 that seemed to play a pivotal role. This gene was expressed, or activated, at much higher levels in the volunteers who didn't go on to develop a sustained infection. In other words, higher expression of HLA-DQA2 was linked to a stronger, more effective immune response, allowing the body to clear the virus before it could cause significant harm. The implications of this finding are profound. HLA-DQA2 could serve as a marker of protection, a genetic flag that indicates a person's likelihood of resisting severe COVID-19. This gene could be a key factor in why some people never get sick, even when exposed to the virus, while others do. Implications for the future. So, what does this all mean for the future of public health and our ongoing battle with COVID-19? The researchers behind this study believe their findings could be a crucial step towards better preparedness for future pandemics. Understanding the genetic and immunological factors that confer resistance to viruses could inform the development of new vaccines and treatments that are more tailored to individual immune responses. Imagine a future where, based on your genetic profile, doctors could predict how your body might respond to a new virus and take proactive measures to enhance your protection. This level of personalized medicine could drastically reduce the impact of viral outbreaks and save countless lives. Moreover, the identification of genes like HLA-DQA2 opens the door to new research avenues. Scientists could investigate how this gene and others like it function, potentially discovering ways to boost their expression or mimic their protective effects in those who are more vulnerable to infection. This research also has broader implications beyond COVID-19. The principles uncovered here could apply to other viral infections, helping us understand why some people are more susceptible to illnesses like the flu, common cold, or even more severe diseases. By unraveling the mysteries of the immune system, we can build a more resilient global population, better equipped to face whatever viral threats lie ahead. The findings from this study provide a fascinating glimpse into the complexities of the human immune system and its interaction with viral pathogens. The fact that some people can be exposed to COVID-19 and remain completely unscathed is a testament to the incredible power of our body's natural defenses. But more than just a curiosity, this research offers practical insights that could shape the future of medicine and public health. As we continue to navigate the challenges posed by COVID-19 and prepare for potential future pandemics, understanding why some people are more resistant to infection than others could be the key to developing more effective strategies for prevention and treatment. The discovery of genes like HLA-DQA2 is just the beginning, and it's an exciting time for researchers and healthcare professionals alike. So, the next time you wonder why some people never get sick, remember that the answer might lie deep within their DNA, and that knowledge could one day help protect us all. Stay informed, stay safe, and let's keep exploring the incredible world of science together.